All right, now I want to review how can we do these same problems, but using the rules of multiplication and division. When we added and subtracted, we were looking at the place value. Is it in the tens, the ones, or the tenths, hundredths, thousandths, or 10,000ths? Or the numbers in the hundreds place, or things like this. But in multiplication and division, we don't care about place value, because when we multiply and divide, the numbers get so much bigger and smaller. It's not about the place value, but about the number of significant figures. So, in 12.5 and 13.5, when I multiply this in my calculator, it told me 168.75. That's what my calculator said. But now I need to use my big brain. How many significant digits are in 12.5? There's 3. 1, 2, 3. Here, there's 1, 2, 3. So here, I can't have all 5 of these digits. I only have precision up to 3 significant figures. So I will go with the first 3 digits always. But look, this 7 is big, which means I'm going to round up, which means my final answer is 169. Here, 2.0 has 2 significant digits, 1, 2. This has 1, 2, 3, 4 significant digits. In my calculator, when I multiply, I will get 6.912. Do I want 2 digits, or 4, or 6? No, I want 2. This is my worst measurement. 2.0, that's very little precision. That's not much. This is much more precise. I wish that all my measurements had 4 significant digits, but they don't. So I can only give you an answer up to 2. So I will take the first 2 digits. That looks like 6.9. That's only a 1, so I round down to 6.9, not up to 7.0. Over here, 0.33. How many significant digits is that? The 3's are significant, but the 0 at the beginning of a number is not significant. So that's only 2. Well, that means, gosh, there's only 1 significant digit there. That's very imprecise. When I multiply, my calculator says 0.198, but I can only have that 1 significant digit. But there's a 9 there, so I want to round it up. So my final answer will be 0.2 or 0.2. These are the same number. I like to put that 0 there myself because it makes it easier to read, but 0.2 is also correct. Here, I've got 1, 2, 3, 4, 5, 6 significant digits because zeros in the middle of a number are significant. That is a very precise measurement. 3.2, that's only 2 significant digits, much less precise. When I multiply those, my calculator will tell me this. But that is also 6 significant digits. That's too many. I'm only allowed 2 significant digits. So my final answer is 32. Or I can write 32 point. That's also correct. The same way these are the same, these are also the same. Now let me move the camera. All right. 456 divided by 123. Well, I can see that this has 3 significant digits, and that also has 3 significant digits. So my calculator gives me lots of digits. My calculator says 3.7073, that's a 0, 171. Ah! I'm only allowed 3 digits. So I need 1, 2, 3, but look, that 7 means I'm going to round up. Now for some reason I saw a lot of students round in weird ways. This will only round up this next digit. So my final answer is 3.71. Over here, when I divide this, my calculator says 810. This has 1, 2, 3, 4 significant digits because zeros at the end of a number with a decimal are significant. This number only has 1 significant digit. I like this example because when we added and subtracted, they both had precision up to the thousandths place. So that was good, but when you multiply, now this only has the 1 significant figure, which means my answer can only have 1 significant figure. So I start at the beginning. That means I can't have that 1 there. I'm not allowed. So I will write 800. I could either round down to 800 or up to 900. 810 is closer to 800, and that only has the 1 significant digit, so 800 is my final answer. This has how many significant digits? 2. This also has 2. So when I divide, my calculator will tell me 0.007. Well, gosh, I want 2 significant digits, and this only has 1. So I have a problem. How can I add a significant digit? How can I show you that this is more precise? Well, we learned that if you add a 0 at the end, that is sending a message to you that this is more precise. It has 2 significant digits. So my final answer is 0.0070. My last example here, 8,000 point has 4 significant digits. 4,001 has 4 significant digits. So the calculator tells me 1.9995012. Ah! I can only have 4 significant digits. I gotta cut this off. So 1, 2, 3, 4. But that 5 tells me I can round up. So how do I round 1.999 up? It's 2.000. I need to include those zeros to show that they are significant, that I did measure all the way to 4 digits. But 1.999 is right next to 2, so it's 2.000.